Hello everyone, my name is Junlin Xu. I am a principal software engineer in the Microsoft Customer Success Engineering team. So today I'm going to talk about how one can leverage and integrate the power of Office 365 through our co-authoring and file synchronization protocols. Here is today's agenda. So first, I will give a basic introduction about Office Online. So Office Online and Office 365 is literally the same thing. You can call it Office Online or Office 365. It's all the same thing. And what is behind the scenes of Office Online is the WOPI protocol and FSSHTTP protocols. So I will talk about these two protocol family, and then I will give you guys a bunch of resources which will be used to learn about what I have talked about. Office Online, from the name, you will be able to know basically like it's online version of the Office product, right? And today the world is cloud-based world. Office Online is we put the Office files into the cloud storage, and we will be able to access it from any device as long as you have the internet connection. Previously, it's on-prem like Office. Like you need to install the Office application in your local machine and open it from your local PC. But Office Online provides the ability to see you can open, to view, and to edit the Office file which are hosted in the cloud storage without actually install the Office applications. So it's combined the basic Office feature and it also allow the real-time co-authoring. At the right side, you can see that's a screenshot I made. As two people actually can edit the Excel file content at the same time. Here is how Office Online works. Very briefly, architecture view of the what happens at the backend for Office Online. So Office Online is based on browser. So first is a layer of a browser, and then browser contains the host frame, which is pointed to the cloud storage for our Office files. And here I write as SharePoint, but it can be replaced by any cloud storage. In Microsoft, we provide like OneDrive and Office 365 service as those like cloud storage. And inside the host frame, there will be a app frame. What is app frame? App frame is like what you can see the file content which are rendering over there looks like the Office application, right? So that's the work of the Office Online application server. It actually read the content and then render everything show as Office application to the end user, like in the application frame. So the host frame itself provide a iframe which point to the app frame. So here is like how WOPI get into the play, right? SharePoint hosts the file itself themselves in the cloud storage, and Office Online application server is responsible for rendering the file using HTML to the end user. So the cloud storage and the Office Online application server have to communicate and do the work, right? So that is the WOPI protocol responsible for. Talk about WOPI. Why you guys care about WOPI? I have said in the previous slides to see WOPI is a protocol talking between the Office Online server and the cloud storage, right? So today, our Microsoft provide our own document host, our own cloud storage for Office document. We have Office 365, we have OneDrive, we have SharePoint, right? But what if you guys want to provide the cloud storage, right, to host the Office documents for your customers, right? If you provide the cloud storage for this document, and then you also want to provide your customers the ability to view and edit those Office files through our web browser, basically the similar experience as Office Online, then you have to implement the WOPI, right? Because WOPI will define the communication and the operations between the cloud storage and Office Online server. So here comes the MS-WOPI protocol. So this protocol is very critical for you to integrate into the Office 365 stories. As I talked in previous slides, this protocol defined two important things. So first, a set of operations that enable a client to access and update the file stored in the cloud file storage is like read and write, and it also describes the communication between the Office Online server and the WOPI server. The communication here means what is the request and response look like, what's the format of those messages, and so on. Here I list the most important operations which WOPI supported. I will go through them one by one so that you guys will get a better understanding about what is WOPI and what WOPI can do for me. First is about WOPI discovery. Is basically negotiate the capacity between the Office Online server and actually the cloud storage for our Office files. Why we need those like as we said before, the cloud storage provides the host frame for the application frame, right? The application frame actually is the iframe which pointed to the Office Online server. So the Office Online server might have different endpoint for different view. For example, the edit, the view only, they have different endpoint. And that Office Online server, you might choose to support only a limited features out of the full feature list, right? So to get the cloud storage and the Office Online server aligned, we have to negotiate the capacity between these two servers. So that is WOPI discovery. It only needed to happen once when we set up the connection between the Office Online server and the cloud storage. It will be triggered by the administrator to negotiate from a backend admin tool. So once the negotiate is done, and all the settings and configurations will be stored in the cloud storage for the future operations. And then after discovery, we can actually performs operations of Office Online, right? There's a bunch of operations. First is about the metadata operation. Metadata is a data exchange which is not related with the content of the Office files. It's basically the metadata. The typical operations is like delete a file, rename a file, the file size, and who edited those files previously, like those information. And then we also provide a bunch of operations actually to operate the content of the file. Two typical the operation. First is get file, right? Get file is Office Online server actually read the file content from cloud storage and then render it to the end user. And the second, put file. Put file is like whoever the end user edits the file in the Office Online server app frame, and after we done that, we have to put the change back into the cloud storage. That is a put file. And since this is an online version of Office, right, there will be a bunch of people accessing the file at the same time. We need to implement the lock, right? The basic operation is I check out the file and lock it so that other people cannot write into the same content to bring in the conflict. So after I do the authoring and then submit the change back to the server, we need to unlock that content. And another thing is a refresh lock. Refresh lock is like when we lock files, there is the expiry time over there to make sure like some of the file content will not be locked forever, right? But if you are still working on that document and that expiration time is very close to expire, you will need to refresh the lock to let the server know I'm actually still working on this part. Please give me a new expiration time. So that is a refresh lock. So those are the most important WOPI operations. And if you want to know more, the protocol itself, MS-WOPI, covered much more details. So now let's assume we have already implemented the WOPI protocol on top of your cloud storage solution, right? Now the end user, your customer, can view the Office file content and they can edit the Office file content online or through any device wherever they have the internet connection. This is good. But what is the next step? What's the gap between this solution and the Microsoft Office 365 solution, right? And one of very exciting feature Office 365 provide is the multi-user co-authoring feature. What is that? Like, let's take our brain back into the old days without the Office Online solution. Like if we have a huge document which require different people to write their content into this document, how did we process? Like someone initialize the document, finish his part, and send it to the next one, and the next guy update his content, and then send it to the third guy, and then we send it back to the whole people to review the content, right? So that's the old days of how we process this without Office Online. But today with Office Online solution is we put this file on the cloud storage. Everyone have the access, and everyone who need to contribute to this document can edit his part in the same document at the same time. That is multi-user co-authoring feature, which everyone loves that feature. So that is what FSSHTTP can help us on. And in addition to that, FSSHTTP also provide the incremental file sync capacity. The incremental file sync, take an example. If you have a file which is over 700 megabits of data, without FSSHTTP, without the incremental file sync, whenever you edit that file and submit, even it's a small character change, the file content actually as a whole needed to be put back into the server. The 700 gigabits of content needed to be put back into the cloud storage, even the change is a small character, if we don't support the incremental file sync. And FSSHTTP provides the incremental file sync ability is that we contain the change into a small unit. So whenever there's a change, let's just upload the unit of the change to the server. the major content of the file which we have not touched should not be put back into the server. This is a huge save of the network cost, and it also saves the server input and output capacity a lot. So that is what FSSHTTP provide to us. Talking about multi-user co-authoring capacity, we know that lock need to be put into place, right? Because we do not want like a lot of users editing the same content at the same time, which bring in the conflict and we cannot resolve. So that's why we need lock. And let's first take a look at the traditional exclusive lock, which we already implemented into WOPI protocol. So this kind of lock support single user editing. It's like one user can edit the document at one time. Like they will not allow multiple users to edit that document at one time. So that will support single writer and multiple readers online at the same time. In the FSSHTTP, we import the concept of shared lock. And shared lock enable two things. So first, it allows multiple writers to edit the document at the same time, but they are writing into the same document, but not at the same piece of the document. Because for lock to work, it have to lock a small like piece of content as a unit, right? And also the shared lock have to support the co-authoring client, but it also need to support as a client which does not support the co-authoring, right? So that is what a shared lock does. Like the mailbox is an example to see if we don't support the co-authoring feature, the client, if that client doesn't support, let's open all the box all at once, right? But if that client do support the multi-authoring, multi-user co-authoring feature, let's just open that small piece of the lock to support this feature. So that's the concept of the shared lock. So we have covered how the shared locks works for FSSHTTP, right? But for the locks to work, it has to be placed on something. So here comes FSSHTTP object graph. So for each of the document, we first chunk the document into different units. We call them cells. The one cell is a unit of lock, which means for the multiple user to do the co-authoring, they can work on different cells on the same document at the same time, but they cannot work on the same cell at the same time. So each cell will be a unit of lock. And inside each of the cells, we chunk the file content into the different objects to achieve the much better performance of the incremental sync. At the right side, you can see the image to see like I have a cell which contains 4 objects, right? If I only modified one object, then the revision 2 of this cell will only contains the changed object of which is object C, and it also contains the reference which point to the revision 1. So by doing this, we have the history of all our changes, and we also minimize the content we communicate from the server and the client. So the same concept is very similar to the GitHub, how they manage the revision and the change. So we just covered very briefly how the co-authoring and the incremental sync works through FSSHTTP, right? So now let's dive into the protocol. So FSSHTTP protocol family contains a few different protocols. So the first one I want to talk is the FSSHTTP protocol. So this protocol defined the format of the message we exchanged from the client and the server. It's like what is the request looks like, what is the response looks like, right? So FSSHTTP protocol request is kind of unique because to achieve the better network performance, we compressed a lot of requests into a package. We call them request package. And each of the requests can depend on other requests. So that is very unique. But the performance is very good. The detail is covered in this protocol, MS-FSSHTTP. And this protocol also covered the high-level information about how we should chunk a file into different pieces. Like we need to chunk the file as the content partitions, metadata partitions, and we should also provide a place to store our status for our logs and so on. Here are the other three protocols in the FSSHTTP protocol family. We have talked about how the object graph works for the incremental sync. But that is how logically things work, right? But to make that logic work, those objects need to be physically stored at some place. That is a storage graph. So both the object graph and the storage graph information are defined in the protocol FSSHTTP-B, right? And then for different applications themselves, they have their own preferred way about how to chunk the file content into different object graph. So that file was defined in two different protocols. The first is a standard for like Word, Excel, PowerPoint is like FSSHTTP-D protocol. And OneNote have its own special way of chunk the file content into different object graph. That is MS-WOPI protocol. So that's the other three protocol of the FSSHTTP protocol family. I have covered major content I want to present today. Here are more resources if you have interest to learn more. So first is a doc help at microsoft.com. If you have any question about our interop documents like WOPI, FSSHTTP, just send the email to that email address for help. And we also have the open specification developer center, which contains a lot of information to help you guys. And on GitHub, we also developed a test suite to help you guys if you are interested in develop the solution based on WOPI and FireSync. That's all for my today's presentation. Thank you.